Welcome kids, here's our video for Algebra 2, Graphing Radical Functions. This is in your online book, Chapter 6, Section 8. So I expected to be making this video on my couch with our 2-hour delay, and it didn't happen, and I know we're probably all a little bitter about it, or maybe not, I don't know. What I do know is that it's time to graph some radical functions, so let's get started. Okay, the radical function is an inverse, so that's actually how we're going to start. We're going to talk about how you can actually take the exponential function, the polynomial function, y equals x to the n, and find its inverse, and that's going to give us the radical function. So let's go ahead and actually find that inverse, and we're going to do that by switching, remember this from class, switching the x and the y, and then solving for y. And that means we have to take the nth root of each side. And the nth root and the exponent n will cancel, and we get y equals the nth root of x. Okay, y equals the nth root of x. So that's your exponential function, and you can have your square root function, which would be y equals the square root of x. And we're going to actually go ahead and graph that. And what we're going to be doing in this video is looking at graphing mainly the square root function, so this one right here, by transformation. So let's graph y equals x squared and y equals the square root of x on the same coordinate plane. So I'll make the y equals x squared blue. So remember that's 0, 0, 1, 1, and 2, 4. And let's see, negative 1, 1, and negative 2, 4. And we get a parabola like so, and that's your y equals x squared. Now let's graph y equals the square root of x. Well, 0, 0, still on the graph, because the square root of 0 is 0. Make a quick little table of values here. The square root of 1 is 1. So again, 1, 1. Now I can't put 2 because the square root of 2 is not something that's graphable. So if I put 2 here, I'm going to have square root of 2, and I don't want to graph that, so I'm not going to use that one. So instead, let's pick a perfect square to plug in for x, like 4. And the square root of 4 is 2, so the point 4, 2. So you should be noticing something at this point. And the square root of, let's do 9, is 3. So it would be here. And it looks like at this point that's all I'm going to be able to fit. And I get this curve like so. Now you should remember from class that when two functions are inverses, they are reflections of one another over this line that I'm drawing in green here, which is y equals x. That's y equals x. So these are reflections of one another, except you'll notice that you don't have the bottom half of that red graph, because you can't plug in a negative, or you can't get out, a negative for y. While you can't plug in a negative for x, you can't get a negative out for the y. So the points on the bottom of this graph are not possible. Now, if you wanted to set it up where you could have the points on the bottom of that graph, what you would need is, instead of y equals the square root of x, you would need y equals plus or minus the square root of x, and that would give you the bottom half of the graph. And so let me just sort of sketch this real quick, like that. But see, that's not what we're talking about here, because we're not talking about the plus or minus, we're not talking about that graph with both, because we're talking about functions, and that would not be a function. It would fail the vertical line test, so it would not work. Okay, so, and of course now I can't delete this blue part, so you're just going to have to pretend that I didn't draw it. Anyway, we can see that they're inverses. We can see that they reflect. Let's start doing some graphing by transformation. All right, we're going to use 3 different colors, and we'll start with our parent function in red, y equals the square root of x. So remember, that's going to be 1, 1, 4, 2, 9, 3, let's see, 16. So 9, 10, 11, 12, 13, 14, won't fit. Parent function. Excellent. All right, so now we're going to do vertical shifts. So remember, vertical shift, that's up and down. It's on the outside of the radical sign, the outside of the function. So let's make this one blue. What's going to happen to all of the points on the graph, y equals the square root of x? Where they're going to go? Down 3. And there we go, and there we go, and there we go. What about this one? Y equals the square root of x plus 2. All of the points on the red graph will go up 2. So it looks a little strange. The graph's just sort of floating out there in space because it doesn't start at the origin or the other one that's below. And so That's what you get with a vertical shift. Let's look at some horizontal shifts. All right, so again, let's graph square root of x. 0, 0, 1, 1, 4, 2, and 9, 3. All right, now vertical shift. Label. Yoink. All right, so vertical shift this time, or excuse me, horizontal shift. So remember what happened here, counterintuitive. We have a +4 inside that radical sign. So instead of moving to the right, which is what you'd expect for plus, it moves every one of these points to the left 4. So I can plot my points there, and then this one, right there. And I got my graph. Good. All right. Other one. -1 moves all my points 1 to the right. So remember how we used this analogy? We said that it starts late or it starts early. And so you get the shift to the left with addition, to the right with subtraction. Good. Let's look at some stretches and shrinks and reflections. Okay. Again, going to graph the parent function. Always a good idea to have it on the screen so we can look at it, so we can compare to it. And when you graph, when I have you graph in class, that's actually how I want you. It's a little messy, but it'll do. That's actually how I want you to do the graphing. I want you to graph by transformation. So it means sketching the parent function and then using that parent function to transform the other one. Okay, that's better. Sorry, got a little hyper about it. All right, so 0.25x. So in this case, that's a shrink because 0.25 is less than 1. So it's making all our y values a quarter of the size of what they were before. So that means that 0 is still 0 because when you plug in a 0 there, you'll still get a 0 out for y. So we'll do a little blue table for this one. If you plug in a 1, you're going to get a fourth or 0.25. Okay, if you plug in a 4, out comes a 2 when you find the square root times 0.25, you're going to get 0.5. When you plug in let's say, the 9 square root of that is 3. 3 times a fourth is 3/4 or 0.75. All right, so that's going to give us a very short, squat little graph. So 0, 0, 1 1/4, okay, and you kind of have to eyeball it here. 4 1/2, and 9 is at 3/4. So you get this very slight square root graph. Awesome. Let's look at this one. Now we have not just a stretch. This one is a stretch. It's going to make it 3 times taller, but it's also, look at this right here, a reflection. So it's not just 3 times taller, it's 3 times taller and flipped upside down. So 0 will still be 0. So that point is still there. If you plug in the 1 for x, you're going to get out a -3 for y. So you would have the same graph, but it would stretch 3. So the same graph, 1, 1, but it would stretch 3, but then it would be reflected. You see how I drew that there? So that would be down here. Same thing with the next one. Now, unfortunately, I can't fit that on my graph, so I'm just going to have to draw this kind of, just flies right off the graph. So it stretched it out 3 times, and it reflected it by flipping it upside down. Okay, what would be some other points on here? If you plugged in a 4, you would get -6 out. Square root of 4 is 2 times 3, -6. Plugged in a 9, you would get, so those of you who have bigger graph paper, in case you want to graph more of it, you get 3 times negative, it would be -9. So that wouldn't fit quite on my graph, but you see how that would work. Okay, let's put it all together. So this is a great little summary of the transformations. So you have your parent function, and we'll look at some other radical functions in class. We only did the square root functions here in the video. The reflection over the x-axis is where you put the negative sign out front. A stretch or a shrink, so we have a factor of a out front. Horizontal shift on the inside of the square root sign, vertical on the outside. Same thing over here, except nth root instead of just square root. So go ahead and take a second to copy that down, and we're going to do, go ahead and graph one with all of the different transformations together. Okay, let's tie it all together. We're going to graph the original with y equals the square root of x. And I won't say I'm cheating, but I am using my graphing calculator just to make life just a tad easier here. So let's graph the original, and please don't hesitate ever. You are allowed to use your graphing calculator. It is your resource in class and at home. Alrighty, so let's look at where these points would go. So 0, 0 would still be 0, 0, except there's going to be a horizontal translation of 3 and a vertical translation of 1. You're also going to have a reflection over the x-axis, so it's going to be reflected over the x-axis. It's actually easier, I found, for this particular graph to go ahead and use the transformations from left to right. So start with the reflection. Okay, this one won't actually do anything when it's reflected. And then half size won't change anything about the 0, 0 point either. Horizontal translation of 3, vertical translation of 1, and we have our new origination point, 3, 1. Okay. All right, next one. It was 1, 1, half reflected, so over the x-axis, half size puts it at -1/2. Horizontal 3, vertical 1, and there we are right there at 4, 1/2. Okay, good. Next one. 4, 2, reflect, half size. Horizontal 3, vertical 1. There we are right there at 7, 0. And the last point we can do, half size, reflect. Oh, it doesn't matter which way I do it, I guess. Reflect, half size. 3 horizontal, 1 vertical. And that puts me at 12, -1/2. And that is how we graph by transformation. And you can use your table function on your graphing calculator to make sure you have the right points. I know I did, and I definitely do have the right points there. Yes, I do. And that's going to be it for this video, except for one more cute image that I found for you. All right, I hope that wasn't too painful, and I hope it didn't end up too long. See you guys in class.